People tell me that this is with the x. They say this is with the x, so it's 3 to the left. And I say to you, but it's not in brackets. And you say to me, but it is. And I say to you, you put the brackets on. And you say to me, it's in brackets. And we fight on the test about this. If you put the brackets, they didn't exist. You put them there, okay? If you wanted to add brackets, you can, absolutely. But the brackets would only go around the x, like that. So is that a horizontal or a vertical? Vertical. If the brackets are typed, if I type the brackets and they're on your test physically typed, then it's a horizontal. If you make them there, that you just force it to be a horizontal, but it's not actually. Okay? Now we call them horizontal phase shifts and vertical displacement, only for trig. But we do. Okay? So it's called horizontal phase shift. To the right, to the left. Okay? Or vertical displacement. I don't think there's going to be any trickery like horizontal displacement and vertical phase shift and see if you remember the words. So honestly, if you just look for vertical or horizontal, you'll be okay on the diploma, right? But that's the proper terminology. So this here would be a vertical displacement. 3 up. So let's imagine we have our little sine graph. Our sine graph starts at 0, 0, right? And then it goes up, and then it goes down. It goes up, and then it comes down. Starts, and it goes up to 1, and it goes down to -1, right? Our basic sine graph. Well, what are we doing with our basic sine graph? We're taking this basic sine graph, and we're going zoop, up 3. Okay? So now our minimum was at -1. It's now going to be at +2. Our maximum was at 1. It's now at 4. But it was like this. I just moved it up. Did I stretch it at all? Did I shift it this way at all? No. Did I make it wider or narrower? No. I just went like this. Shoop. So does that change my amplitude? My amplitude is how high it is from the bottom to the top divided by 2, right? So did that change? No. Same height. Did the range change? Yeah, my range used to be -1, 1. It's now 2 to 4. How did I do my range? Remember, my minimum was D plus the absolute value of A. Minus the absolute value of A. And my maximum is D plus the absolute value of A. Remember? Our D's on all the last lesson were 0, so it was easy. The D in this case is 3. What's my A if it doesn't exist? 1. It can't be 0. If it was 0, the whole thing would go away. A has to at least be 1. B has to be at least be 1. C and D could be 0, right? I could move nowhere horizontally and nowhere vertically. I'd be fine. But I can't have a no stretch, or it would be a flat line or a flat line, right? They have to be at least 1. So my minimum for this one is going to be 3 minus 1. And this one's going to be 3 plus 1. So it would be 2 and 4, like I said. So my range did change. Because before it was -1, 1. Did the period change? Because the only way the period changes is if I have a horizontal stretch, right? My domain change? Nah. X-intercept, did they change? My graph was like this, which meant I started at 0, 0, which is 1 x-intercept, and went like this, right? Okay. Now my whole graph is 2 to 4. Did my x-intercepts change? Yeah, I went to having x-intercepts to not having any. So vertical translation does change my x-intercept. What about my y-intercept? It was at 0, 0. It's been shifted up. Did it change? Yeah. How can the range be obtained? Well, we did it already. So we can go y such that 2 is less than or equal to y is less than or equal to 4 IER, or 2 to 4. Okay? What's this one? A vertical displacement to what? What's my range? How would I do it? Well, in order to do range, I have to have the minimum and the maximum. Minimum is D plus the absolute value of A. What's my D? -2. What if this was in brackets? What if this was x minus 2 in brackets? What would my D be? Nope. This is in brackets. What would my D be? Plus 0 at the back, right? So it's going to be -2 plus 1, because my absolute value of A is 1, which is -1. Oh, -1, -1, -1, -3. I keep trying to add it first. I really should do max first, it seems. And then it's going to be -2 plus 1, which is -1. So I was at -1 and 1. I'm now at -3 and 1, right? I'm not moving it. I'm just moving this up. I want you guys to try 3, 4, and 5. Honestly, all I want you to do is this column here and this column here. I want the range. So I want you to give me the transformations, and I want the range. Okay, so what's this one? You guys are going to just shout it out to me. Vertical stretch by a factor of about the, yeah. What's the 2? A what? 2 what? 2 up. Okay, what's my minimum? It's going to be 2 minus 3. I just put it a plus again. Seriously. I really just should write max. This seems what I want to do. -1. And then max is 2 plus 3, so 5. So for ease, I'm going to do this. On the next one, I'll do interval. Or this is interval. I'll do set. Okay. This one, vertical stretch by a factor of 2 about the and what's the 3? Vertical displacement 3 down. So my D, now you guys, that D, if you haven't noticed, okay, and the first ones, our D's were all 0 yesterday. Our D's were all 0. We actually had a line at y equals 0. It's called the midline or the median line. It's the line that cuts the graph in half. So yesterday, for all of our graphs, they were all completely, this is not looking like it, they were all completely central along the x-axis, right? So our D was 0. So our line was y equals 0. It's called the midline. Our D actually gives us that middle line that cuts the graph in half, that horizontal line that cuts the graph in half. It's called the median or midline. Okay, if you say midline, you have to give a line, so you have to give an equation. So that's why it's y equals 0. In this case, it's y equals -3, which makes sense because our midline yesterday was at 0, but I'm moving the whole graph down 3. So that little line that was at y equals 0 is now going to be at y equals -3. And if I go up 2 from there and down 2 from there, I have the graph drawn. Okay, because my amplitude is how much up and how much down there is. Okay, so the range in this case, I start at -3 and I go down 2. So I get -5. Then I start at -3 and I go up 2. So I get 2, -1. So I have a midline at -3, at y equals -3, and I go up 2. So I'm now at y equals -1, and I go down 2, and I'm now at y equals -5. So that's why D plus A and D minus A works, because you take that middle line and you just add the amplitude or subtract the amplitude, and it gets you your low and your high. Okay? And then you squished everything in between. So y such that -5 is less than or equal to y is less than or equal to -1. And then this one is what? A horizontal phase shift, because it's in the brackets. pi over 2 right. What's great about transformations, it doesn't matter what equation you get, they all follow the exact same thing. So once you know your transformations backwards and forwards, every single unit give you a new transformation, but you're like, this is easy. It's the same thing every single time. It's with the x. If I had myself a horizontal stretch sitting in front of here, I'd have to take it out just like I had to do before. That does not change. That's why I said on the diploma, the chance of them making you pull a horizontal stretch out is about 100%. If they don't, I'd be very shocked because every single unit we do transformations and it's the common error to not pull it out, right? So they can put it into every single equation. So the fact that they probably are going to have a horizontal stretch that you have to pull out, I would say is pretty high, like 100%, maybe 99.8. They might not, probably will. Okay. And then this one, my D is 0, my amplitude's 1. So I'm still going -1 and 1. Why? Because I was at -1 and 1, and all I did was I moved the graph pi over 2 to the right. Did I change my height at all? I'm just rolling along this way. I'm not doing anything. So my amplitude didn't change, so neither did my range. So -1 and 1. But you can use D plus A, D minus A, right? Same thing. Alrighty. Now comes the fun part. We're going to flip ahead these 2 pages to this one, if you have them printed, just for now. These ones are a little bit more difficult. So, this is where it gets a little more difficult. It's not hard. You just have to pay close attention to me. Okay? Very much close attention. If there was a phone out, I would not have it out because you will be lost. And I find that I'm grateful because you're all here. The attendance is great. Whoever misses this class, it's like they never catch it, ever. It's like the whole semester goes by and they'll watch podcast and they never get it. I'm glad you're here. So, okay. What was the difference between a sine and a cos graph? What did we decide? What was the difference between a sine and a cos graph when we looked at them yesterday? The y-intercept, that was different because what did we do to them? Yeah, they're just a pi over 2 shift away from each other. So if I shift one of them pi over 2, they actually end up being exactly on top of each other, correct? They're the exact same graph. So all they are is a horizontal shift difference, right? So their A's are the same, their B's are the same, and their D's could be the same. The only thing that's not the same on them is my C's. So that's the hard part. That's the thing that's harder to find. That's why in 30-2, they don't have to find the C. They have to find the A, the B, and the D. They don't have to find the C. The old applied curriculum, they did have to. The C is the hard part. Okay, so when we look at any graph, I'm going to actually make you find 4 equations for each graph because they could ask you to find one of the 4. So we have to be able to find all 4. What does it mean, all 4? Well, my amplitude is great because it's the absolute value, so it's always positive. My A value could be it could be negative or positive, right? But my amplitude, we just take the absolute value of that and we get it. So we're pulling the amplitude off of a graph. But when we put it back into the equation, it could be negative or positive A value, right? So we're going to find the negative and the positive A value for sine and the negative and the positive A value for cos. But we're going to do coses first because they're easier. All right. So what's great about them? For number 5, you find the A, the B, and the D the same. So once you found them once, you have it for all 4 equations. It's the C that's the difference. Okay? So A of my equation is my amplitude with plus or minus signs, right? How do I get my amplitude off of a graph? You can go from the bottom to the top and divide it by 2. Or you can use that formula, which is the absolute value of max minus min divided by 2.